All right, so I decided to do a few instructional videos on these water potential problems. I know that they can be difficult, and just wanted to do them out so that you guys can see, exactly how to set them up, how to do them, what the answers are, all of that. And then also that you can refer to this when you need it. So I'm going to start with the first three in this video here. Okay, so first of all, this is the directly from your formula sheet that you get for your exam. And so, that is there for your reference, but you also have your sheets that you can refer to. Okay, so for this first problem, okay, we are going to calculate the water potential of a cell if a cell's pressure potential is 3 bars and its solute potential is negative 4.5 bars. Give your answer to 1 decimal place. Okay, so this is just taking the idea of the equation that water potential is going to equal your pressure potential plus your solute potential, okay? And it gives you pressure potential and it gives you solute potential. Okay, and so that water potential is fairly straightforward and easy. You're just going to do an easy calculation on this one. So this one's an easy one. All right, so we got our water potential is going to equal our pressure potential, which right here is 3 bars, plus our solute potential, which in this case is negative 4.5 bars. Okay, and when we do out that math, you're just plugging it into a calculator, 3 minus 4.5, and you're going to end up with a negative 1.5 bars. Okay, and that's your answer for that first one. Okay. All right, next one says, identify in which direction water will flow if the cell from question number 1 is placed in a beaker of sugar water with a solute potential of negative 4 bars. Okay, so for this one, we are taking our cell, which for our cell in the first one, the solute potential was negative 4.5 bars. Okay, and actually, let's take a look at that water potential. The water potential is negative 1.5 bars. So we're going to put that cell, negative 1.5, into a beaker of water that has a solute potential of negative 4 bars. So that is not water potential, that is solute potential, okay? So what we want to find is the water potential of outside the beaker here, okay? So it's this simple calculation again. We're doing the water potential is going to equal the solute potential, I should say, make it the same as the formula here, the pressure potential plus that solute potential, okay? Now this is a beaker of water, and so we should know, and if it's not given to you, that pressure is going to be 0 because it's an open container, so there's going to be no pressure, okay? So we have our water potential is going to equal 0 plus our solute potential, okay, which they give to us in the problem as negative 4.0 bars, okay? And so that water potential is going to equal negative 4.0 bars, okay? And so now we have our negative 4 on the outside here, okay? Now remember, water is always going to go from a higher water potential to a lower water potential, okay? And in this case, we need to, this is something that, we need to remember. Negative numbers, okay? Negative numbers can be tough because, we tend to think of numbers as positive. But here we need to remember negative 1.5 is greater than negative 4, okay? So knowing that, this is a greater water potential, this is a lesser water potential, and so water is going to go out of this cell, okay? And the question, always go back to the question. Identify in which direction water will flow if the cell from question number 1 is placed in a beaker of sugar water with a solute potential of negative 4 bars. Okay, and it says, remember the equation over here. Okay, and so to answer our question, identify in which direction water will flow out of the cell. and that's what you would write, okay? So water will go out of the cell, okay? All right, next one, number 3. The original cell from question 1 is placed in a beaker of sugar water with a solute potential of negative 0.15 MPa, megapascals, okay? We know that 1 megapascal equals 10 bars. Oh, there's the bars, okay? That makes a little more sense. Okay, so identify which direction water will flow. So in this one, it's just basically we need to know what that 1 megapascal is for bars, and we're gonna convert this to bars, okay? Because bars is something that we can work with here, okay? All right, so we have our solute potential of negative 0.15 megapascals, okay? By the way, megapascals are something that I'm not sure you're gonna see on an AP exam. It's something we don't see often, but we should be able to take one unit and convert it into another if they give us the conversion, which they do, okay? So we know that 1 megapascal is 10 bars, so how many are 0.15 megapascals? So we just do a simple calculation, okay? So we got negative 0.15 times 10, okay? That is going to give us our number of bars, okay? And so this is going to be negative 1.5 bars, okay? And so it says identify in which direction water will flow. So the original cell is placed in a beaker of sugar water with that solute potential, okay? And so we know our solute potential is negative 1.5 bars. That we can compare now to our cell, all right? And so let's draw out our beaker again. Drawing out the beaker really helps. I like to do it. I would recommend doing it. I think it's helpful, okay? And so we're taking that original cell from question 1, which remember had a water potential of negative 1.5 bars. All right, so we're gonna put this here, negative 1.5. It is going into our beaker that has a water potential of negative 1.5 bars from this problem here. We just did it out, okay? So negative 1.5. And oh, look at that, they are equal, okay? So identify in which direction water will flow, okay? This is an isotonic solution here because you have equal water potentials, and so you're not going to get water flowing in one direction. Water will be flowing, water will still be moving, okay? But it's going to move in both directions here, and so you are not going to get a net movement of water. So there is no direction for the net movement of water. Because the solution and the cell have equal water potentials. Okay, and I abbreviated there, but they have equal water potentials. You would write that out, okay? All right, so these first 3, not so bad. Hopefully you guys understood that. I'm going to do the next ones in another video.